Engineering Center, and it's on synthetic intelligence partner with my glass on, apologize. Synthetic intelligence partner with machine learning, and we have Dr. Louis Mazziotta to talk to us today, and I'll ask him to come up, and I think he's got some interesting things to show you.
Good afternoon. So my name is Louis Mazziotta. I'm from the Armored Research Development Engineering Center, Picatinny Arsenal. I've been invited or asked to come down here and talk to you about some of the prototypes or things that I've been working on. I actually gave a speech at the Mad Scientists Conference on artificial intelligence, machine learning, and autonomy. And at that conference, we played this game of, hey, what if? And some of those what ifs, I envisioned this concept of something called a battle buddy. I'm a former soldier, and as a soldier, we have a buddy, a battle buddy, who will assist us, or we will assist them. We watch each other's back. So I got to thinking, with machine learning, what we're going to be capable of, what are we going to be capable of building with this technology? Well, one of the things I thought we can come up with in the next few years is this battle buddy, this synthetic intelligence, this partner that could be out there in the battle space with me. I think of it as an 18-year-old or 17-year-old young person leaving basic training, leaving their advanced individual training, and then ending up in a unit. And a lot of times you get mentoring from people with experience, and those folks will help you through things, and that gives you confidence, because you may not feel confident to work on those systems. You may not feel confident to engage in those tasks that you're being asked to engage in. But if you're there with somebody experienced, then that person will help elevate your confidence. And you might make mistakes, but at least if you make a mistake and somebody's there that knows what they're doing, that it's not going to be a complete failure, or you're not going to be the reason for a catastrophic problem. So now let's go to the battle space. I get out there, and I'm a young person, and if I'm out there with somebody who had multiple tours of duty and has been in a firefight, I'm going to feel a lot better than if I'm out there by myself. But what if I had this synthetic partner, this intelligence system, who was kind of watching my back, that had that experience ingrained in it? And that system will give me that confidence. There was a chat bot. There was a couple of them, actually. Microsoft Tay was one, and that kind of went a little off the rails. And then the Chinese had a chatbot that after a few days, people were trusting it and confiding in it. And they were telling this chatbot things that they wouldn't tell another person. And that made me think, wow, so if you go and sit down with a psychologist and you have some issues, how does that person get you to talk to them? Well, they must be trained in the right way to ask the right questions. They must be trained in the right way to enunciate, how they inflect their voice, to invite me to feel trust, to talk to you, and then to accept what you're saying so that I can buy into it. So if that chatbot was doing something like that, if this intelligence system was communicating in the right way, asking the right questions, and getting the responses, trust was forming. There was rapport forming between this artificial entity. So I said, wow, imagine we had this on the battle space. Imagine we had soldiers that could have this partner, this cognitive partner. And what if I give this cognitive partner some sensors? Say omnidirectional camera, say sensors localized to that soldier. And what if I can extend it, connect it to a network, whether the network's there or not, but I'm enhancing the value of that partner. So it seemed to me that, wow, this would really tackle a lot of problems, especially if we have natural language, and we're working toward natural language. If you have natural language and I can start talking to this thing, and this thing starts talking back to me, then let's think of like Maslow's hierarchy of needs. In Maslow's hierarchy of needs, before I can step to the next level, the first thing I have to feel is secure and safe. If I don't feel secure and safe, I'm not going to move up to another. I'm not going to worry about food if there's imminent danger. I got to get out of here. I got to protect myself. So now let's go back to that battle space. There have been times when I have to look at a map and I have to decide what's my next action. If that choice that I'm making is being disrupted by fear, or nobody's got my back, I'm on this on my own, how much time, how much commitment can I have to making the right decision? Am I wasting time getting to that decision that could cost me my life? So deciding faster is based on getting the information faster and getting good information, which gives me confidence that the decision I'm going to make is a good decision. So I'm on that battle space, I'm looking at a map, or I got to make a decision about something, but I'm also worrying about my safety. But if I have a few soldiers with me and they got my back, then I can focus on, hey, the plan. But if I'm by myself, how do I do that? So I said, well, what can we do now? Can we do anything now with off-the-shelf technologies? Can I glue some of these technologies today and create the first kind of step toward that battle buddy? And what we have right now is they have some predictive algorithms out there in machine learning. They have visual systems that do classification. I said, oh, there, I could do that. I could take a classifier and I'll let this machine look at some video or images and tell me what it sees. And so I told the story to a few folks that walked by, but if I'm at an outpost and nobody's supposed to be in my area of operation, then simply saying, tell me if there's people or an animal or anything living in my area. And now I can focus on my work, or I can focus on what my mission is. And then all of a sudden, my synthetic partner is scanning the information. Humans, we focus in very tight areas. We have the binocular vision, but we need movement to draw attention, right? Prey freeze. They freeze so they can get beyond that predator's ability to see them, to acquire them as a target. But a machine doesn't care if you're frozen, doesn't care if you're moving, and it can look at everything in an omnidirectional manner. So now if that partner of mine has eyes everywhere, and I've asked that partner to notify me when these things of interest are in your view, then I can free myself and move up that hierarchy of need to do something more meaningful. So what I did was I basically used a commercially available machine learning system that does classifications of photos. It's in the cloud. I glued it together. I gave you some eye candy. I glued it together. First iteration was a single camera. Second iteration here, starting to look in multiple directions. We want to use a spherical camera. And in this case, the city represents the front, and the scene on the other side where I stuck a little tank in there, that represents the back view. The silhouettes will indicate when the haptics are fired. And the checkboxes, that's my intent. I'm telling the system, these are the things I want to be aware of. Currently I believe I checked tank, and I wrote the word business in the free text box. If I were to come over to so what's happening is the images were being viewed by a machine learning classifier, and with confidence scores next to each word, it's giving me some labels back and saying, this is what I see. And when those labels match what I'm interested in, I send notification. So if anybody, I've got a couple of volunteers that may want to come up here. No? Okay, come on up, both of you. We'll tell the next part of the story. So this is my buddy. He lost his head over this. If you feel the mannequin, you'll notice that there's a red light blinking on the front. That's when the haptics on the front. So if you touch it, you'll feel a vibration when that light lights up. You can hold on to it. So what's happening is they can see in the back there's a blue light, and that's when it's the back image is telling it something. And the red light in the front is associated with the front haptics, and that's when something in the front view is being seen by the cognitive system. So this is a very simple setup, but it has a lot of power. Because if we were to train it to find weapon systems, things of interest, even if it was a search and rescue operation, and you're flying over and you're just looking for anything, and you can get a high-res cam and get enough information in, or integrate other sensors so that you get more meaning from that space. You can see that already we could actually build systems that would provide an enormous amount of information to a soldier. But not just provide information. When I was in the Army and they said, you know, if somebody yelled grenade, you didn't think about anything, you just drop. Just drop it down. And one of the things I asked one day is, oh, we keep doing the same thing over and over and over. It's getting like monotonous here. And I remember the drill sergeant saying, well, that's so you don't think about it later on. You just act. You're going to basically decide faster. You're not deciding anything. You're getting that muscle memory. You're getting used to doing that same repetitive thing. Has anybody been stung by a bee? Yeah. What happened when you got stung? You remember how fast you reacted? That tactile sense. Nobody yelled bee. You didn't hear the buzz. You felt that, and you reacted fast. So the combination of the haptic sensors, it got me thinking. I know that response for visual cues, average person about 300 milliseconds to respond. The response to an audio signal, a human can react, I looked this up, is about 170 milliseconds. And that's because visual processing in our own brains takes more than audio processing. But tactile processing, down to about 140 milliseconds. So I can cut my reaction time in half by feeling it as opposed to hearing a warning or seeing a warning. So I'm on the battle space and I'm in a firefight and somebody's trying to tell me duck. If all those haptics light up, I could duck. And if that thing that's telling me is my cognitive partner, just saved my life if I'm ducking and that was the thing I needed to do. I brought with me, anybody, you guys know what a TENS unit is? You know what a TENS unit is? For those that don't know what a TENS unit is, it stimulates your muscles. They use it in recovery for physical therapy. It's a little mild shock. You can adjust the voltage and the frequency, and you can feel it. And so I made up a little device, and it actually could drive, the system can drive that. So you can imagine that if you had conductive fabric, and instead of driving motors, there's just little impulses. Those little impulses, if they're mild, it just may mean to get your attention. But if it's a grenade, maybe I want to just shock you quickly. You know, get your attention, drop, like that bee sting. So it's just a combination of technologies that are currently available that we can integrate and then improve upon and get me to that battle buddy where I have a cognitive system that I can communicate with natural language, that can give me more confidence because they're talking me through a problem that I haven't experienced before because they are that expert in that system. And I mean, this is what I think we can do today. I think this is how we can get to improving upon the technology. Everybody, you know, we have these great ambitions about, well, let's make this fully autonomous thing that we can talk to and it's going to clean my kitchen and start cooking for me and clean the house and drive the car. Yeah, those are all great things. But there are things we can actually do right now and make quick use of the technology. So it's more of a freestyle here. So if anybody has any questions, I'd love to talk, and answer your questions. I'm really about just having a conversation. I'm a futurist. I love technology. Hey, thanks for coming up. I appreciate it. Do you guys have any questions about? Good, sir.
What classifier do you use to get those costumes in?
The commercial classifier that I'm using right now. You mind if I tell you offline?
Yeah.
I'll tell you offline. Yes.
How do you test the human response? I mean, if there are a lot of false alarms, do people trust it? What happens after a month of using it? Does it work?
So this is good because when I think about like artificial intelligence, I'm a computer scientist, and when we do software engineering, we always want to be able to take a requirement and test it, trace that requirement all the way to the function. And we know that that's not the case with these neural networks. We're training them with data sets, and there's a confidence level we hit. So you have to think about, well, if we don't want to use that, say, immediately in something that knowing, in a deterministic system, I have to know the result. That's not the best choice for the technology, in my opinion. However, if I could say, hey, look, right now you're relying on each other to be aware of something. If I can 90% of the time steer you away from harm, would you want that added capability? So sure, 10% of the time I might be wrong. You're going to duck for no reason. But if 90% of the time I'm saving your life, can we accept that? And that's how we look at it. Because that's the only way I see of doing it right now until we come up with a better way of determining, given this stimulus, what's the response I'm going to get out of that system. Does that answer your question?
It does. It's not that simple, right? I mean,
No,
the
it's
guy
not.
who yells grenade because someone tipped over a coffee pot, you're gonna laugh at him. But if it happens every 20 minutes, you're gonna get rid of it.
Yeah, and that's why you pick the confidence. I like to look at it this way. If you look at the results of that, it'll say 97% it's this, 95% it's that. So we can improve upon that, because what we can do is we can do it in the context. We could use other technologies and hybridize it. So we're not just using, say, the one system. We'll use multiple technology. We'll use some traditional approaches paired with some, new technologies, or we'll use the context of the results. Yes, you said tank, that's a toy. But if I had ranging information, I had something that determined size, I hit it with radar, I'm getting a reflection from it. In the context of the sensory data, I could say it's a toy or it's a tank. But the ability to get that initial information, pair it with some other information, and get that response back to me so that I can act upon it, and that's the decide faster. Yes?
Just trying to get clarification. There's an image of a city there, right?
Yes.
We're also talking about assisting the warfighter in theater, right? So I'm trying to figure out, are you making a parallel there? Or, because if I look at this photograph, right, one of the things that come to me from a classifying perspective is you could get so many false positives there, right? Because, it's a crowded community. Sure. How do you really tell the neural network what to look for? On the flip side, when you think about theater, our soldiers are fighting more and more in unknown territories. How do you preconceive a neural network system for an environment that we're not familiar with?
Because I wouldn't try to understand the whole environment. I would try to understand the targets. What am I looking for? Not can I understand the environment itself. For example, if I've trained it well enough that it understood what a firearm was, any kind of firearm, just like if I go back to my child looks at a cat and goes, "Daddy, what is that?" And I go, "Cat." And then, we walk along down the street, and now a dog walks by, and he goes, "Cat, Daddy?" And I go, "No, that's a dog." And the kid's scratching his head because you just told me that was a cat. And after enough data sets, then the child says, "Oh, I now see the difference between dog and cat." Did the environment play any role in that understanding of what a cat and a dog was? It could have been in the street, could have been in the backyard.
Yeah,
the target.
But that's apples and grapes.
I'm sorry?
That's apples and grapes. I think you're mixing apples and grapes because, when you think about a cat and a dog, right, you're talking about visual classifiers, right? But when you think about in theater, right, the environment is going to dictate the image that the classifier detects, right? So you could tell it, for example, I may age myself here, but if you remember in Gulf War I, Saddam Hussein massed the Scud missiles with images that we thought was real images, right? We probably didn't have machine learning going back then, but if we had told the classifier to look at different kinds of visual for SCUD machines, we would have been hitting cardboard SCUD machines, right? So one is visual, but one is also dependent on the environment. I'm just saying that there needs to be a synergy.
No, so
between the two.
now we're talking about, synergizing all the sensory data. I think if you looked at, say, a radar signature, and on a radar signature I said, that looks like it might be some kind of mechanized vehicle moving toward me, and I got a visual image that says, yeah, that looks like it could be a tank. So at a regular traditional programming level, I could take that information and then make that determine the same way I do as a human. When I look at things, I use the context of the information. So in this case, the cat and the dog example in any environment is still a cat and the dog, no matter how the environment is perceived. If we go over to that box and you stick objects in there, or we change the scenery, it's still going to say tank. It'll see other things, but it'll still see tank. And if my interest is in tank, then it doesn't matter what the environment looks like. All I care about is there a tank in there? Is there a weapon in there? Is there a person in there? I don't care about the scene. I didn't ask it to classify every pixel in the scene. I just want to know if those things of interest are in this scene, in this environment. So I'm saying we could use that technology now, and the confidence can go up as we get better and better at mixing those various sensors together and making better sense of the data. Because it's all data, right? The picture's data, the sound's data, the radar information's data. It's all data. We just have to make good sense of it. And if we can cluster that data where it provides meaningful sense, then we're going to get useful information that we could act on. I think I'm taking up too much time. So, oh, no, I'm not sure. Do we have somebody coming up? So, is there any more questions? Go ahead.
Do you work across the other labs also?
Me personally, I will work with anybody to help our warfighters. I don't have a problem with working with anybody. I've reached out to as many people. I worked on a program one time, and I don't do that kingdom thing. I like to solve problems. That's what I like to do.
Like this is like a soldier thing, and it's hard. So
That's not the area that I make decisions. I just had an idea and I presented it. Where it goes from there, hopefully it gets to the right people and they get to use something that helps them. So I hope that answers.